In this lecture, we are going to develop the axial dovetail route. To start with, let us first see the drawing. You can see this is the drawing, and let us find out where the route is. If you see here, this is the route. And to develop this route, we require a cross section. Here, we have taken the blade. Here, if you see, this is the front view of the blade, and this AA cross section is somewhere here along the y-axis, and this section view you can see somewhere here. If you see here, this is view C, which is shown in an enlarged section view here. All the dimensions of the route have been shown here. Now, to generate this route, if you see here, this is the plane on which we have to create that section. So, let us move over to Solidworks and let us activate, or so to say, show all the planes. These are all the default planes. I will show it. You can see on this right plane we are going to create the section. So, let us take sketch and select this right plane. It has come in this orientation. We are going to create the route somewhere here. So, let us go to the drawing, and if you see here, this is the profile of the route. We will create half of this profile, other half we will mirror. So, to create half of the profile, what I have done is, as you will be confused by the orientation of this Solidworks, you can see it is something like this, and orientation of the drawing. So, I have simply rotated this view so that it will help you to imagine the drawing better. Now, we will create a rough sketch something like this. Let us do it. We will take line, and I will simply create a point on this plane and move to create a vertical line, a horizontal line, an angular line, and you can see I will create a point on this plane, or I can create somewhere here and move and create a point, you can see, on this plane. This has become an angular line, so I will click it and create it as vertical. Click on OK. Now, first thing I have to do is I will select this line and this plane, collinear. Click on OK. Now, let us give the dimensions. We have created the rough sketch. Now, we will give the dimensions. To start with, first dimension that I want to give is from here to this plane. This width I want to give. So, if you want that width, then here if you come here, if you see, this is 4.9. This dimension is 4.9. Press on the enter key. Now again, I will take the drawing and I will give the next dimension. This is 56 degrees included angle. So, from here to here, we will give 56 degrees. It's done. Now, let us create the next dimension. If you see here, this angle is 101 degrees. So, I will take this line and this line, and between this, the angle is 101 degrees. We have got a message which says that, do you want to create this as driven? Because here you can see a perpendicular constraint has automatically been created. So, I will remove this perpendicular constraint, just select it and delete. Now, the dimension is free. So, I will select these two lines and we will give a dimension 101 degrees. You can see. Now, there are few things left. If you move this, there is a dimension here. At certain distance, see, at 5.9 mm from the base, a dimension has been given here 14.8 mm. So, this we have to give. Let us first draw a center line or any reference line up to this plane. You can see up to this mid plane. Yes, I have done it. Now, if I move this, it will move like this. So I'll just select this and this origin point and make them horizontal. Okay. Let us give the dimension from this line to the base. This dimension is 5.9. So at 5.9 mm, this dimension is how much? If you see here, it is 14.8. The total is 14.8. So as it is symmetrical, so we will take 14.8 divided by 2. Press on the enter key and you can see. Now let us move this line. You can see there is a dimension left here. Let us find out what is the dimension. Here if you see, there is a radius R1 and the tangential relation between this arc and this arc is given as 18.9. Let us give that. First, let us create this radius R1. Let us zoom in a bit and we will go for fillet and the radius is 1 mm. I'll give 1, press on the enter key and now I will select this point. Click on OK. You can see radius 1 has been created. Now this is 18.9. So we have to take this tangential point of the arc with respect to this center line and give this dimension 18.9 divided by 2. Let us do that. We'll take smart dimensioning and if you take this arc first and go for this point, then you will get the dimension from this center point to this point. We'll take a center line or you can take a line and convert it into reference and we'll make it horizontal. You can see. Now we'll take this line and this arc and make them tangent. You can see. Now let us take smart dimensioning and give a tangential dimension between that arc by taking this line and this center point or so to say the origin point. Now this dimension, if I show you here, 18.9 divided by 2. So let us give 18.9 divided by 2. Press on the enter key and you can see this entire thing is black, but we have this dimension left. So we will take smart dimensioning from this line to this plane. This dimension we have to give. Let us find out where the dimension is given in the drawing. Here the dimension is not given. If you come over here, the dimension is given here 15.4 from this base to this top, 15.4. So let us give a value 15.4. Press on the enter key. The sketch is fully defined. If you see here, it is fully defined. Now let us go for mirroring this half sketch. To complete the sketch, we'll go for mirror entities and entities to mirror. Let us select this line, this arc, this line and this line. These are the lines we want to mirror and mirror about this plane. This is the plane. See, a preview has been shown here. This is what we want. Click on OK. And if you see here, we have got a fully defined closed sketch. Now let us exit the sketch. We have generated the cross section of the root. Now let us go to feature, extruded boss or base and select this sketch. Now let us create the extruded boss or base by taking this sketch. Click on this sketch and if you see, a solid is being formed. You can just drag it somewhere here because we are going to cut this portion in the next lecture. And here in direction 2, this also I will drag and keep it somewhere here and click on OK. We have created the root. So now the aerofoil body is ready and the root is ready. So we are going to give some finishing touches to the model in this lecture. We will start with this fillet radius. There is a transition radius here. Let us give that. If you see here, it is R3 all around. That means this entire transition is of radius 3. Let us give it. We'll go to features and here we'll go to fillet and select this edge. You can see I'm able to select the edge, and if you come over here, we can give the radius. We'll give the radius as 3 mm all around. You can see it is showing a preview. Just click on OK and the radius has formed. Let us hide all these planes so that we can see the model clearly. Let this plane be there. Now, the next thing is, if you see here, this length of the root we have not given. If you see the drawing here, this is the length of the root, that is 39, but it is oriented at 25 degrees. So, let us give this length and create the root. Also, if you see here, from this axis, it is 21.5 mm. Let us create it. Here, we will create a sketch on this plane. You can see, and let us create a rough sketch, something like this. We'll create an angular line, and this may be any kind of profile you want. It doesn't matter. Again, this side also we'll create an angular line and create a profile. No need to constrain it, only we will constrain these two lines. Okay, before that we have to create a reference line. So, we will take this origin point, you can see, and create a line something like this. Also, let us bring back the plane. This is the right plane which we want. We have to give the dimension. So, we will take this line and this plane. Between them, the dimension is given as 25 degrees. So, 25, enter. Now, let us convert this line into reference. So, we have converted this into construction geometry. Let us give the other dimension. From this line to this line. Now, this is at an angle. So, we will just remove this dimension and we will take this line and this line, and between them we will give a parallel relation. Similarly, between this line and this line we will give a parallel relation, so that we can give the dimension from this line to this line, which is the perpendicular dimension, and the dimension is given as 21.5. Press on the enter key. Now, let us give the total dimension from here to here. This total length is given as 39 mm. Both these lines are constrained, so that is all what we want. Other lines you need not constrain, because those things will be just out of the 3D model. So, I will go for exit sketch. Now, let us go for extrude cut. We will select this sketch and flip the direction, and I will move a little bit up. You can see. Now, the similar thing, I will just select here, I will go to sketch and select this sketch also, so that both of these at a time I can cut. Click on OK, and you can see we have created the root. So, everything we have done, but one thing we have left out. We have created the aerofoil body by using these 5 sections. If you see here, the total height from base is given as 90. So, this we have not done till now. So, let us cut this blade at a height of 90 mm. Let us go to reference geometry and let us create a plane. I will select this bottom plane. You can see this is the bottom plane, and we will give a distance of 90 mm. Click on OK, and the plane has been created. This is the plane. We will go to insert and cut with surface. Click on this option and select this plane. Now, we want the direction in which you want to cut. You can see this upwards we want to cut. Click on OK, and you can see the body has been cut about this plane. So, this is what we want. Now, let us hide the planes. All the planes will hide. Select this plane and this plane and just hide it. And if you see here, The blade is ready. This completes the 3D modeling of 5th stage compressor rotor blade. As this is the first project, so we have done lot of new things in this project. We have seen how to create the aerofoils, we have seen how to feed the data into the coordinate data into Solidworks and create the aerofoils, and we have also learned how to study the engineering drawing of an aero engine blade.